All right, welcome back. We are in the skinny packet. We are on page 31, and we are moving into section 8.2. And this time, we're going to take something that's in standard form. So that's SF, and we are going to move it into this new form that we're not quite used to yet, called Vertex Form, which we will abbreviate as VF. And remember, Vertex Form looks something like this. All right, so we got the three forms: standard form, factored form, vertex form. And what we've done is we've worked in our last section of how to go from standard form to factored form by factoring. This process to go from standard form to vertex form is known as completing the square. All right? So let's start with this. A perfect square is a number that can be expressed as the square of an integer. For example, 9 is a perfect square because it's equivalent to 3 squared. So let's actually talk about why it gets the name square. So imagine this is a square. And if you were to find the area of a square, you take the length times the width, the base times the height, and we're going to assume that this square has all the sides equaling 3. So 3 here, 3 here, 3 here, and 3 here. And if I wanted to find the area, I could take the base times the height, the length times the width, whichever you want. And that's 3 times 3, or we've learned that it's 3 squared, and you get 9. So this is why it's called a perfect square, because you can actually make a square out of it. So now what's going to happen is our square is going to have a little bit more in it. So that's supposed to be a square. It looks more like a rectangle. But anyway, we're going to assume that this side represents the area and this side represents the side squared. So according to this, instead of my side of my rectangle just being 3, it's x plus 2, x plus 2, x plus 2, x plus 2. And if I want to take and find the area, I'll just take length times width, base times height. So I can take x plus 2 times x plus 2. And instead of writing it twice, I can realize I can write it once squared. But what happens is when you do this, you'll have your neighbors start to meet, right? There's x squared. I'm going to really squish this in here. 2x, and then the 2 goes to meet everybody. You get another 2x, and then the 2 meets the 2, and you get a 4, and it's x squared plus 4x plus 4. So again, this is just a square. If I actually took the time and had x minus 3 multiplied to itself, you would get x squared minus 6x plus 9. And for this one, if I just took x plus 6 times itself, which is what the squared is saying, I would get x squared plus 12x plus 36. So maybe we can try to visualize that one. So here's the x squared, check. Here's a 6x and another 6x, which makes the 12x. And then when 6 multiplies to 6, I get the 36. So maybe the more you do it, you can start to see that. So what we're going to do is we're going to determine which of the following are perfect square trinomials. We're going to circle all that apply, and there can be more than one factor. So the idea is what was happening here is, I was showing you how to get from factored form to standard form. Now we're in this part, we're going to go from standard form back to factored form. So let's make our first x. So multiply the outside of 36x squared. This is the bottom. And our factors that will get us there will be a negative 6x and another negative 6x. When I add these, I get negative 12x. And when I multiply these, I get a positive 36x squared. So now I'm ready to go into my factors or my neighbors. And again, we always start with the neighbor that met the neighbor to get us our leading term. So x and x meet to make our leading term of x squared. Now I can draw my focus on the sides. And x times what can make this? That would be a -6. And then x times what can make this term? That is another -6. And if you notice, your parentheses are identical, and you can, instead of writing it twice, you can write it once squared. Next step. Let's switch colors. So I'm going to make my x. So 25 and x squared go on the top. -10x goes on the bottom. Here are my factors that work. When I add these, I get -10x. When I multiply them, I get a +25 and an x squared. So I'm going to go straight to my neighbors or my factors. And again, our first goal is the neighbor that met the neighbor to get our leading term, and that's an x and an x. And I'm going to draw these loops and focus on my side numbers. So who does x meet to make -5x? That's a -5. And who does this x meet to get the other -5x? And that's a -5. So again, what will happen is you will have identical parentheses that instead of writing twice, you can write once squared. So some other things I want you to start to notice is that your side numbers are identical. So the same thing's going to happen on this one. Here goes my x. I need factors of 81, x squared, that add up for -18x. And you're going to see the same pattern, that these numbers are going to be the same sign. So what number times itself gets me to this is a 9x and a 9x. I will have to make them both negative to get this -18x. So when I add these, I get -18x. When I multiply these, I get 81x squared. Now I'm ready to go to my factors. And who are the neighbors that met to make our leading term? That is just an x and an x. And again, focusing on these side numbers, x times what makes -9x? That's a -9. And then x times what makes that -9x? That's another -9. So instead of writing twice, we can write once with our parentheses squared. So as it turns out, these all work. Circle all that apply. A perfect square trinomial is a trinomial that has identical factors, and you can write those identical factors as one thing squared. And again, it's called a perfect square because the square can have dimensions of x minus 6 times x minus 6, and when you take the length times the width, or the base times the height, or just take one of the sides and square it, you get this, which is technically its area. I hope that makes sense. So how do we complete the square? Your goal is, when we're done factoring, is that we will always have two sets of identical factors every single time. So we'll kind of walk through that a little bit, but eventually we're just going to find a shortcut to this. So the first thing is there is a catch. In order to complete the square, this has to be in the form x squared plus, and then it doesn't really matter what else is attached. So if you are noticing a number, a coefficient, multiplied to your x squared, you will have to GCF that out. So what we're going to do is we're going to move the constant over, we're going to leave a blank to complete the square. That's not what we're going to do. I would have changed these directions. So what we're going to do is we are going to move the constant over, but what we're going to do is we're going to group our x's together first, and you're going to leave a space here. And then we're going to leave our constant on the outside, and you're about to do this. So let me explain why I have a plus a blank and a minus a blank. The reason why is when I'm done with this, as I start to work through all these equivalent steps, I can't change what this equation is worth. So if I add something, like let's say I end up adding 2, then I've made this worth more than what it is. So if I add 2, I'm going to have to quickly take away that 2 to keep it worth 3x squared plus 12x plus 4. So we are going to move the constant over, that's fine. But also what we're going to do is we're going to group our x's together. And so the parentheses are kind of separating the x stuff to the non-x stuff. Now what we're going to do is we're going to divide out the leading coefficient. So we will be dividing out a 3, factoring a 3 out of here. So I'm going to divide that 3 out, and you're left with x squared plus 4x, because when this distributes back in, you get this. When this distributes back in, you get 12x. So it's still the same. I'm going to keep this blank and this blank. And now what you're going to do is it's going to say complete the square by using this formula. So you're going to notice where b is. B is the part that happens. What you're going to do is you're going to take b, you're going to divide it by 2. Once you get that amount, then you're going to square it. So here, and I suggest you always write this out, you're going to take 4, you always cut it in half, and then you take that number and you square it. This is the number I'm about to put in the blank. So I'm putting a 4 there. So if I've just added 4, that means I have to take away 4 really quick. This is the most important step. You have to bunny hop to keep the expression equivalent. Bunny hop is this. So remember how this 3 was in here because it's really 3x squared? And then this 3 goes to this term, distributes, and it's really worth 12x? Well, that 3 is technically also, here's the bunny hop, distributing to this 4. So even though I wrote 4 down, it really is technically worth 12. So since I've just added a 12 to this whole thing, that means I'm going to have to go over here and take that 12 away really quick. All right? Most important step there. From there, what we're going to do is we are going to factor these parentheses. We're going to simplify, so let's put little things that match. We're going to simplify the outside of the parentheses as well, and that's this part. So let's do the factoring part first. So I'm not forgetting about this 3. Here comes the factoring part. So again, I need factors of 4x squared, that when I add them up give me 4x, and according to this they should be identical numbers on the sides. So factors of 4 that add up to 4 are a 2 and a 2, and notice I'm still putting the x. So from there I can go to my parentheses, and the leading term, the term that met the term to make our leading term of x squared is x and x. And now I'm going to focus on the side numbers. X times what can make this 2x? And that's a plus 2. And then x times what can make this 2x? And that is another plus 2. So again, a perfect square trinomial always has identical numbers on the side. And then you'll always have identical factors, which instead of writing twice, I can write once with the squared. Here comes the 3. It's still there. And now I'm going to go to this part that's underlined in blue, and I'm just going to do 4, take away 12, and I get minus 8. And this is vertex form of what we just started with. All right? I know, that definitely seemed confusing. So let's try another one. I assume there's, yep. And then I'm going to show you a shortcut. Okay. Let's start with this one down here, example 5. So the first thing we're going to do is we are going to group our x terms together. And as I do that, I'm going to be leaving a blank. The non-x term does not get to be part of it. It has to be outside of the parentheses, but I'm going to subtract a blank. The next thing is this only works if it's x squared. So I will be factoring out the leading coefficient. So I will force myself to factor out a 4. So I'm dividing this by 4, and I'm dividing this by 4. Everything else is just being copied. And now what we do is we take this number, we cut it in half, and then we square it, which I realize that's the same number as before. That's just coincidental. And 2 squared is 4. And 4 is what I'm going to add here. But this is where the bunny hop comes in, because that's, again, really 4x squared. When this bunny hops in, that's really 16x. And when this bunny or neighbor meets, you get 16. So even though I wrote 4, it's technically, because of this 4, worth 16. So it looks like I added 4, but I really added 16. So that means I have to subtract 16. From there, we're going to go to our trinomial, and we are going to factor it. So I need factors of 4x squared. Again, I realize this is the same one as before. I don't really care for that. That gives me 4x, but I guess it's kind of nice because we still already know that our parentheses are 2x and 2x. So now let's find the factors, or the neighbors, who made this trinomial. So the x and the x are what we worry about first, because x and x make our leading term of x squared. And then we can focus on these side numbers. So can I take x times something and make 2x? That's 2. And can I take x times something and get 2x? That's a 2. And again, instead of writing these as two separate factors, you can combine them and write them as one factor squared. Here comes that 4. And then I'm going to come over here and simplify the stuff on the outside of the parentheses. So 4 take away 16 is a negative 12. And now you have vertex form. So again, just to verify, we just went from standard form to vertex form, and this whole process is called completing the square. All right? Okay, let's try some now, and I'm going to show you some shortcuts, because what we don't want to do is factor this every time. All right? So I wish there had been different numbers, because this would actually show up a little bit better. Let's just go to this one up here. So the first thing I'm going to do is group my x's together. And as I do that, I add a blank. There's the minus 10, doesn't make it in the parentheses, and I'll subtract a blank. And then you're going to take this number, you're going to cut it in half and get 3. And then you're going to always square that number, and that's 9. And 9 goes in here, and now I just want to check for a bunny hop. There is no bunny hop, so I really have only added 9, which means I can subtract 9. So this is the part that I want to show you. So one more time to factor. If I did take time to factor this trinomial, so I'd have 9x squared and 6x in the bottom, and the factors of 9 that add up to 6 are 3 and 3. And then I would work on the neighbors of the factors that get me there. And so again, the neighbors that I worry about first are that give me my leading term of x squared, so that's x and x. And now I'm worried about the side numbers. So the first thing, again, that's really important is that these side numbers are always the same. 2 and 2, 2 and 2, negative 9 and negative 9, negative 5 and negative 5, negative 6 and negative 6. So let me show you the shortcut. If you write this step out, do you notice how your cut in half number is this side number? Okay? As it turns out, so here's that number. Boom. Boom. These numbers without the x's are what go in here. 2 and 2. They are what will go in here. Plus 3, plus 3. And then you can just go straight to here of x plus 3 squared, and I didn't have to factor it. And then I'll still simplify this. This is like a negative 10, take away a 9, and that's a negative 19. So that's part of the shortcut. Let's shorten it even more. So again, the first thing I'm going to do is group my x's together. No shortcut yet. Add the blank. There's my non-x term, the constant, with the subtracting blank. Again, we always have to factor out the leading coefficient if there is one. In that case, there is technically a negative 1, which turns this into x squared and turns this into minus 10x. Everything else is just dropped. And I'm going to take this number, I'm going to cut it in half, and then I'm going to square it. Negative 5 times negative 5 is 25. The 25 will go here. And I'm going to check for my bunny hop. So even though I wrote 25, when this -1 bunny hops to 25, or the neighbor meets the neighbor, you get -25. So you really have added -25, which means I'm going to subtract -25. So now what I'm going to do is switch it on you. I'm going to do this simplifying first. -1, take away -25. We should know that's the same as -1 plus 25. So that gives me a 24, positive 24. And now we're actually going to go straight into our parentheses. We know that whatever's in here will have identical factors. We also know from the shortcut is that this number is the side number. Those side numbers are just what's in here. So technically, let's just leave this out and realize that that's going to be the side numbers, which is just this. So I'm going to leave this step out and go and realize, sorry, that my cut in half number is the number that's in the parentheses. And it's always x plus this cut in half number. And the way I remember that is, do you see how there's a squared here and you're going to have a squared here? Whatever number's in front of this squared is the number that will be in front of that squared. And then hopefully you don't forget about that bunny hop number that we took out. And that's it. So for instance, just one last thing and then we're done. Going back to this page now, the previous page, 31. Well, no, I'm not going to do that. Never mind. I take it back because there's some things that we didn't do there. So that is completing the square, and we will practice more in class.